And so I have the pleasure of chairing this session and introducing the speakers. And our first speaker is the Honorable Stephen Chu, who's Secretary of Energy. He's a Nobel laureate, and most importantly, he's a member of the American Physical Society. So I saved the most important title for last, and so I call Dr. Chu to the podium. So, bear with me 1 minute as I plug in my computer. As those of you who know me realize that my speechwriter, that's me, waits till the last minute, literally, every time. And yes, Mike Turner says you can't get help these days. All right, I think I'm all set to go. Let me just stick it on. This is very typical. Let's see, I want to go duplicate. And I want to go, tell me when it's on. Good. All right. So, I was given a title because I probably didn't respond early enough, so they wanted me to talk about photovoltaics, but I just can't do that, so it's photovoltaics and more. And so I'll explain a little bit more at the very end what this picture is all about, Earthrise. So the future of photovoltaics means I have to make predictions. And before I make any predictions, I have to remind you of what the greatest American philosopher of the 20th century said. In case you're wondering who that is, that's Yogi Berra. Here he's shown on the right having a philosophical discussion. And what he said was it's difficult to make predictions, especially about the future. Now, every time I've given this talk and quoted Yogi Berra, someone in the audience comes up afterwards and says, Yogi Berra didn't say that. Okay, it's been attributed to Niels Bohr, Casey Stengel, Mark Twain, George Bernard Shaw, Victor Borge, Confucius, Woody Allen, Dan Quayle, unlikely. But a lot of people have been reputed to say that, but it's true. So I want to bring you back a little bit in history to put all this in context. Henry Ford is one of the great successes of American industry. Just to remind you, he started in 1899, the Detroit Automobile Company. It got disbanded in 1901. He started again in 1901. By the way, he did not invent the assembly line, let alone the automobile or the internal combustion engine. He made the assembly line work better. And then 1901, it started another company. The company brought in and left him as chief technology officer, but they brought in a consultant. He was highly insulted. He stormed out and left the company. Lucky for him, the Henry Ford Motor Company was renamed Cadillac, so he can use the name again. He went around looking for, so company number 3, 1903, he founds Ford Motor Company. His lawyer asks Michigan Bank president, should I invest in this? And the bank president says unequivocally, the horse is here to stay. The automobile is only a novelty, a fad. He didn't listen. Rackham didn't listen, invested $5,000 in Ford stock, sold it later for $12.5 million. In those days, that was a lot of money. There are a lot of other naysayers of this new technology, and that happens everywhere. Whenever there's a new technology, the people who represent the incumbent industries don't want that new technology to succeed, and sometimes they try to help it along in not succeeding. This is a description of the automobile. Stores of gasoline would constitute a fire and explosive hazard of the first rank. Horseless carriages propelled by gasoline might attain speeds of 14, even 20 miles an hour. The menace of our people to vehicles of this type hurtling through our streets and along our roads In addition, the development of this new power may displace the use of horses, which would wreck our agriculture. That was said by someone who entered it in the congressional record. All right. Now, do failures of companies investing in new innovations mean that the technology is doomed or the investments are misguided? Certainly that has been a question raised about the solar industry. This is from Wikipedia. These are the top 10 solar manufacturers in the world. You notice the top 1, 2, 3, 4, 5. Five of the top 10 are from China. For those of you who are paying attention, the top one, Suntech, just declared bankruptcy about 6 hours ago. All the others are in stress but due to overproduction. Solyndra went bankrupt. I get reminded of that every day. Q-Cells in Germany was bankrupt. First Solar, which is a thin film manufacturer, is alive and doing reasonably well because it got out of the manufacturing business and concentrated on the installation business. And LDK, another major company, has slipped. They've defaulted on their loan, so on and so forth. So this is, you say, is this a disaster? Well, yes and no. It's a disaster because there's an oversupply. And that will work its way out within the next year, year and a half. Okay? Let's go back to the automobile. You know, lots of car companies that the older folks remember, Packard, Studebaker, Nash. The younger people never heard of these companies. They disappeared. In 1917, 127 car manufacturers, 26, 43. 1947, 12. In the 1960s, 3 U.S. car manufacturers. Does that mean car manufacturing was a doomed technology? Not really. So we should recognize the difference between consolidation of companies and a doomed technology. Most of those companies have failed or they were acquired by larger companies. And this is what will happen, and it is happening with solar. Now, another great technology invented by Alexander Graham Bell. Just in case, Alexander Graham Bell is the person on the right. Anyway, 2 years after Bell got the patent, he was trying to sell it and get business partners. And again, because of incumbent technologies want to say that this is not going to work, Sir William Preece of the British Post Office said, the Americans have need for the telephone, but we do not. We have plenty of messenger boys. And so this is something that goes on over and over and over again in every technology. There are those who say, nope, doomed to failure. Now, the flip side of this is every inventor, every scientist, every technologist loves their invention. And they perhaps fall so much in love with the invention, they aren't able to step back and have perspective. And this reminds me of this tale, and so you're going to have to bear with me for 2 minutes. It's a tale about a man and woman. They just got married, and the bride, they're being driven off to their honeymoon, and the bride says, well, dear, I have to confess to you, I'm a virgin. And he looks at her and says, wait, you've been married 3 times before. What's going on? Well, certainly there was no premarital sex, but never mind that. He says, oh, my first husband, you know, I was very young. I was 20 years old. He was a father figure to me. He just took care of me. It was platonic. He was a dear, sweet old man. Okay, what about second husband number 2? Husband number 2. Well, I found out he was gay. So we had to split. Okay, I know husband number 3. He was neither old nor gay. What's happening? Husband number 3 was an entrepreneur. Every night, he would sit at the foot of the bed and tell me how good it's going to be. So sometimes you can get enthusiastic about your technology. Let me go back to the automobile, and I'll finally get to solar. It was one of the fastest transformations of major technology which required infrastructure in the history. This is a picture 1890s of New York, horse-drawn carriages. Detroit, 1920, maybe 25 years later. It's mostly automobiles. There's a few electric trolleys, but the automobile companies were going to get rid of those too. And it was a very fast transition. Why? Because in the end it was a superior technology, but it was hastened by an environmental problem. What's the environmental problem? It's environmental pollution. What's the pollution problem? Well, in New York and Brooklyn in the 1880s, there were 160,000 horses, and they produced 3 to 4 million pounds of horse manure a day, and 40,000 of urine. So this manure was piling up in every vacant lot. It was on the streets. The fertilizer market was well saturated. There was businesses popping up where young kids would offer to sweep the streets for the well-to-do patrons of New York City to kind of carve a path so they won't have to walk on horse manure. It was an environmental problem. You will hear later in this session about environmental problems, climate change. I just want to say one thing about that. You're going to hear much more science about it. But if you look at this record from 1800 to 2010 of direct measurements, you notice that the biggest, and these are 4 different studies, you notice that the biggest change occurred over the last roughly, that's a mistake there, roughly the last 30 years. During that 30-year time, and this is data from a reinsurance company, and you look at geological events like earthquakes, that's the dark brown, doesn't seem to be a trend there. You look at storms, floods, extreme drought, temperatures, forest fires, things you might associate with climate change. Certainly the climate modelers associate that with climate change. You see an unmistakable trend of natural disasters in the United States. Worldwide, in terms of most of those losses are uninsured, and the trend line is going from about $40 billion a year in these things that we associate, at least climate modelers associate with climate change. And remember, this is a 30-year record. This is not a 3-year thing. The loss trend line is about $170 billion a year, so it's significant. I'm going to skip the oil dependency. I just want to say that it may have been said by a number of people over the last decades that perhaps as the demand for oil and natural gas increase, what will happen is that just the scarcity and the higher demand will drive the prices up, and then you have to go to renewables. I don't think that's going to be true because the technologies for finding and exploiting and extracting fossil energy, at least for the next couple of decades, 2 or 3, 4 decades, is going to be getting better. Just again, dispassionately looking at the record, even though the demand is going up, the ratio of demand to reserves is remaining constant before shale gas and before shale oil. And that has changed. Shale oil in the United States is going to increase production so that we will be the 2nd largest oil producer in the world, and we may eclipse Saudi Arabia for a decade as the largest oil producer in the world because of shale oil. So now, to this end, I will quote one of my favorite authors, and in a recent article, this person said, "Our ability to find and extract fossil fuels continues to improve, and economically recoverable reservoirs around the world are likely to keep pace with the rising demand for decades." That was me and Arun Majumdar, one of my favorite authors. That's Arun, I'm so sorry. Okay, fixed it. And we went on to say, as the saying goes, the Stone Age didn't end because we ran out of stones. Yes. We can transition to better solutions that are economically viable, and that's what I'm here to talk about, and solar energy. So in the last 1 minute of my talk, I'll talk about PV. I think I have a little more time. Before I talk about PV, I have to declare that I am partial to solar, and there was an article in The Onion that came out February 7th, 2013, And the headline says, "Hungover Energy Secretary wakes up next to solar panel." Washington. Sources have reported that following a long night carousing at a series of DC watering holes, Energy Secretary Stephen Chu awoke Thursday morning to find himself sleeping next to a giant solar panel he met the previous evening. And it goes on to say he couldn't even recall the manufacturer's name. According to sources, Chu's encounter with the crystalline solar receptor was his most regrettable dalliance since 1909, when an extended fling with a 90-foot wind turbine nearly ended his marriage. My wife is sitting there. She took this all with calm and grace. You know, the usual comments, you know, I'll stand by my husband. So we had to react fast. So we put out this release the same day. I said, I just want everyone to know my decision not to serve a second term as Energy Secretary has absolutely nothing to do with the allegations made in this week's edition of The Onion. It's Washington. While I'm not going to confirm or deny the charges specifically, I will say that clean, renewable solar power is a growing source of U.S. jobs and is becoming more and more affordable, so it's no surprise that lots of Americans are falling in love with solar. They would not let me add, regardless of sexual persuasion. So there are limits to the public affairs. So that's full disclosure, I am partial to solar. I'm just going to give you highlights. This is a couple slides from Harry Atwater. I don't know if he's here. But if you look at PV research and development and you look at the efficiency, the cost, everything, and you can divide it into many ways. You can divide it into materials, device design, photon management. And, let me see if, oops, let me go back. All right. So there are ways of improving the efficiency and perhaps the cost performance of solar. You can improve in the light trapping so that you can trap every photon, not have it re-emitted. You can have higher angles of trapping. You can split the spectrum so that instead of a single bandgap material has a Shockley quasar limit, you can have multiple band gaps. People have been looking at this for several decades. The real challenge is to get it inexpensive way. And so this goes on and says, this is, you know, the quasar limit is like 32%, but there's a practical limit if you include all the other stuff, including thermodynamics, that you're about 25%. And so many people have talked about how you can go further, and many of the things, multi-junction solar cells, light trapping. Again, I'm not going to go into this, but the basic idea is the incoming solar radiation comes in, you have it race along on and divide the spectrum. Usually people in the past 2 decades or 3 decades talk about multi-junction on top of one another. The bluest light gets absorbed first, the more infrared stuff or red stuff goes through, it gets absorbed later and takes it by layers. You can take a totally different approach and start splitting the spectrum using what you know about plasmonics and all these other things. So there are a lot of ideas out there now circulating on different ways of splitting the spectrum. There are a lot of ideas circulating out on using SIG's material but tailing the doping so that you don't have mismatches in lattices and all these other things. All possible. This is in play. Okay? I'm not going to talk about light trapping. Very clever ideas. I'm going to briefly talk about an idea. This is from Ziek Shen and his collaborators. I was going to give a talk at Stanford about 3 or 4 months ago, and he writes me an email. I read the Nature paper you and Roan wrote with great interest. I found this statement, integrating photovoltaics in a solar thermal absorber may be possible, allowing both approaches to be integrated, very appealing. And then he sent me this article, Nature Materials. I'll explain what it is. And then on 12th of March of this year, Nature Communication. So what's the idea? You let the entire spectrum heat up the photo emitter. This is on a nano microstructure, so here's the incoming radiation. But this part gets hot. And so when it gets hot, the thermal tail of the energy band gap. So here's the cathode. What you're doing is you're letting this to get very hot, and there's a thermal tail that makes emission much easier to get to the anode. And then you can play all sorts of games. You can make little nanostructures with little points. You can do all sorts of stuff. Now, this is going in the right direction because before, in the normal solar technologies, the hotter it gets, the more inefficient it gets. And so you have to spend a lot by cooling it. But now you're in the exact opposite direction. You're gaining exponentially in the ability to overcome the band gap, the vacuum gap. And it falls very nicely in all the technologies that are being developed. And so it's essentially a thermionic emission, photoemission hybrid. So the Nature Communication article achieved 2%, about a 3-order of magnitude gain in efficiency from the first article. And they say that they think they can get at least another 10-fold gain in the future. And if you go to utility scale, and especially solar thermal, where you can get to very high temperatures, then you can go even higher. Again, it's going in the right direction. It's a materials problem, of course. How do you get materials to keep their composition, their whatever, at high temperatures? But again, one of many, many exciting ideas that give me great hope for the future. Those are the esoteric ones. There are other ones that are less esoteric, and you should always look at the competition because there's something I learned when I was at Bell Labs and beyond, is that gallium arsenide was always thought that it would replace silicon. And then it became, after a couple decades, gallium arsenide, the material of the future, always has been, always will be. Well, I don't think so, but that's the cynic. So, silicon. Half the cost in a silicon module today is the cost of solar-grade silicon. Before you put on any lines, before you do any doping, before you do any of this stuff, if you look at the finished module cost, not the installation, just the module, not the electronics, but it does include the dopes, leads, and the doping, half of it's the cost of silicon and the refining of the silicon. What is it? You take a block of silicon, you saw it up, you use either more recently sometimes lasers, but usually diamond string saws. You're down to a thickness of 200, 150 microns. Half the silicon's lost. You can't recycle that silicon. And so half your cost, half of your silicon, which is a quarter of your cost, is gone. And you're not going to go much beyond 150 microns for a number of reasons, just in the handling of the sawing. Okay, so people are thinking of how do you get Kieferless silicon, lift-off techniques, a number of very exciting techniques. This is one of them. The great thing about this is it's a quasi-epitaxial growth that you can use the substrate over and over and over again. You lift it off. They have already shown 19% efficiency, where you can now, because of light trapping techniques, even though silicon is an indirect bandgap material, you only need 50, 80 microns at most, but you can probably get down to 20 or 30 if you're good at it, okay? Instead of 150, and that's a lot of the cost. Let me also say that most of the silicon solar made today is in these big crucibles. You heat it up, you slowly solidify it. This is high-grade polycrystalline silicon. Only one company is commercially competitive to making single crystal silicon, but most of it is in this way. And so these are big vats of this stuff. Turns out that if you're very, very careful about cooling and see directional growth in this big tub of silicon, you can actually get it to be of single crystal quality over 2/3 of the volume. This was actually demonstrated in a program we, the Department of Energy, supported, but then BP Solar, we were supporting this research in BP Solar, but they decided they wouldn't want to compete and sold off the company and went to a German company. The Chinese are taking this and developing it still further, and we don't know whether this is going to become commercially available in a year or two, but it might. It's very, very serious. So again, that means polycrystalline, which is at 16% efficiency, goes to 20%. So that's 5% over 16 is the denominator. That would be a very big deal. Okay? So don't underestimate silicon. This is solar installation on a rooftop. Now, if you look at the average cost around the United States in dollars per watt, that's standard illumination conditions. So you're factoring out the fact that Germany is in the northern latitude and it's cloudy a lot of the time. Okay, just standard illumination. It costs about $5, $5.50 a watt in the United States to install, full cost of installation, licensing, all that stuff. Costs Germany $2.50 a watt. Solar modules are an international commodity that vary by less than 10%. So what is it? Of course, it's the German labor. No, it's not. It's a lot of bureaucracy and a lot of licensing and a lot of other things that are happening. Let's think of what we do when we install a water heater in your home, either a tank water heater or a tankless water heater. And what are the relative dangers? Do you need a county or city inspector to pre-look at your house? No. Do you need an inspector after you look at your house? No. You have to wait online and have a DMV experience to get the license? No. What is the danger? Well, your roof may leak or get damaged. Here, the danger is higher. There's carbon monoxide poisoning, there's explosion, there's all sorts of things. But if you have a licensed contractor, it's okay. So we have to get, Germany has that philosophy on solar installation. We have to get that philosophy. So we in the Department of Energy have been working on it. This is called balance of system cost. If you take out the electronics and the module and you look at it, the balance of systems, all the other stuff, the installation costs, the licensing are these dark blue lines. This is the cost of the hardware, which is plunging and will continue to plunge. It will drop by at least 2x, maybe 3x in the next 2, 5, 8 years. The real issue is how do you get learning curves on the balance of system? And our Sunshot program manager, Min Lee, said, unlike physics, where we can fundamentally figure out the upper limit for efficiency in solar cells, there is no such limit to bureaucracy. Boy, do I know this. And so we are now, this is where we're beginning to concentrate because this will bring the cost down. A couple more things, and I've got 4 more minutes. There's something else that's coming on the horizon. The cost of batteries has dropped twofold in the last 4 or 5 years. 2x manufacturing costs in batteries, lithium-ion batteries has dropped. We have a target, it's right now about $500, $550 in 2012. This is a year-old slide. We have an aggressive target to get manufacturing costs down to about $125 per watt hour, okay? For sure it will get to $250 in my mind. Within a decade, probably within 5 or 6 years. If it even gets to $250, you have something very unusual. You have for $5,000, go to Costco, you buy 5, 6 kilowatts of battery, including the system. Now you have solar, which we hope 5 kilowatts gets down to $10,000, full install costs, a couple $1,000s more of battery, you're 80, 90% independent of the grid. And your battery can shift the cost from noontime to at night. Whether this happens 5 years, it's probably 8, 10 years from now, for sure in my mind, 15 years from now. You know, this is a new way of generating energy and using energy. And it also can cause a lot of social disruption because those are the upper half of our society that will do this. And then the remaining costs of hookup will go up and up and up because the power generators. So I'm trying to convince them you need a new business model. Why don't you be part of the action? Why don't you install and rent and sell your customer? We'll sell you power cheaper, but you want to use a little bit of your basement, a little bit of your roof. Okay? So that's an opportunity. Let me conclude by saying that Da Vinci said, knowing is not enough, we must apply. Being willing is not enough, we must do. There's another thing that I've been trying to instill upon folks in the Department of Energy, and something Michelangelo said. The greater danger for most of us lies not in setting our aim too high and falling short, but in setting our aim too low and achieving our mark. There's a lot of promise out there. Whether it happens a decade from now, 15 years, 5 years, maybe some of it might not happen just exactly the way we foresee, but don't say, let's go back to the horse and buggy. Now, sometimes my friends ask me, knowing what you know today, would you have agreed to be Secretary of Energy? And I won't go into that. That's another 4 hours. The answer is yes, without a doubt, which is different than what I do for 4 more years. But in hindsight, the time I spent was not about starting energy hubs or RPE or some of the things that are visible. The most important thing I did when I look back on it is I helped recruit very, very good people, great people, not only at the higher levels that are visible, but down at the program manager and sub-program manager level. I get on the phone and say, come on, join us for at least a couple of years. And when those people joined us and they were empowered, it really transformed what was happening. If those of you who know solar have seen it in the Sunshine program. Let me go back finally. What was this about? It's Earthrise from Apollo 8, the first mission that went orbited the moon, and the last orbit, they turned the capsule earthbound and they took a picture of this. And Bill Anders, the astronaut, said, we came all this way to explore the moon. The most important thing is we've discovered the Earth. Since 1968, it is increasingly compelling evidence that we are changing the destiny of the Earth due to climate change. And this is why I became a director of a national lab and why I became Secretary of Energy. And we do have a moral responsibility to the most innocent victims if there is adverse climate change. The poorest citizens of the world who didn't contribute anything to this, and those yet to be born. And let me remind you of an ancient Native American saying, we do not inherit the land from our ancestors, we borrow it from our children. So, that's all I have to say. Thank you.
I think we can all be very proud that a physicist served as the Secretary of the Department of Energy. And before we ask questions of Steve, I think we should all stand and thank him for his service to the nation. Thank you very much. That was really inspiring. So I wish we could have done more blocking and tackling for you. But now are you willing to answer
Sure.
a few questions?
Absolutely.
So let's see if you can raise your hand. I'm having a little trouble seeing. Are there any hands up? Go ahead. Yes, please. Let's hear. Are we bringing you a microphone?
Well, you say it now, and you can test me as that's whether I can remember. Or okay.
And making it usable by the majority of the population. Now, a lot of the U.S. has a lot of infrastructure that's about 50 so years old based on the current paradigm of large plants that burn coal or gas, and it will be very expensive to rejig our infrastructure. And could you talk a bit about how we as a nation can invest wisely to do that?
Sure. So this is a transition that can occur naturally. Right now there's a very, very small fraction, certainly less than a fraction of 1% of rooftops are solar. Renewables in general, let's take out hydro, we're at 4%, mostly wind. But what happens is as the prices of solar come down, and they're coming down very rapidly. The modules, as I said, they came down fivefold in the last 5 years, fivefold. There are already companies that are going into business that go to consumers and say, we will sell you electricity, you let us put a solar system on your roof, and if you buy us from, let's say, 5 or 10 years, we can sell it to you at the same rate, maybe even less rate. But you're not responsible for the solar. We'll take care of it. It breaks, we'll fix it. And we'll guarantee you this price. Okay? In sunnier parts of the United States, that's the new business model already. And so then you see it going to 1%, 2%, 3%. But then there's a problem there because under most, let's say California and a lot of the states, you get to sell back to the power company until you reach zero net use. And this is not a good deal for the power companies because they have to essentially buy back at retail, whereas they're generating wholesale, which is about half the cost. So there's an instability there already. And so what you need to do is to say, let the power companies help invest in this rental. It's just like the old phone system. They didn't sell you a phone, they rented you a phone, you didn't have to worry about the phone. And then they can be a part of the changing market where otherwise if you're a utility company, which is mostly distribution now, not power generation, it's merchant power generation, you see a declining market, that's not a good thing. If you see this other technology come out and you're part of a growing customer base, the companies actually like that because if they have distributed storage and distributed generation, especially areas where it's very sunny and you are very increasingly concerned about summer air conditioning blackouts, they would love to be having to generate solar in those air-conditioned times. And so this technology, if done in the right way, would solve their problem. The consumer won't see an increase in costs, all right? And they will see a decrease, and they will have more reliability, more immunity to blackouts. And the infrastructure is the transmission and distribution system, which is then becomes, in many areas, backup. Okay, just as sometimes you might have a landline, but what is the phone you use the most? Your cell phone. Okay, and so you don't get rid of the landline. It becomes an integral part of it as a backup. And so there's a way to do this that I see can benefit a lot of people. And it could benefit, and it's even better in developing countries.
So we have time for a couple more quick answers. So we have a question here and then a question there, and then we'll go on to the next talk.
A very quick question. I was very impressed with the cost of the batteries going down, but as you know from your laptop, the battery does not last longer, and if it lasts longer, it's due to advances in electronics, not to advances in battery technology.
What's the question?
Can we do something about the...
Yes.
Getting better batteries.
Yes. The target for automobile manufacturers, the real target is 5 to 10,000 discharges in the way you intend to use the battery. By the time you're at 10,000 discharges, moderately deep discharges, you're 10, 12-year lifetime.
I was talking about power density.
Power density. Power density is, there are a couple of designs that are in testing, nail testing, that have doubled the power density that's going to Chevy Volt and Nissan Leaf. There are half a dozen power density, maybe 4 or 5-fold. One very exciting one looks like it could be 5-fold cyclable, but it's still early couple years of experiments. It won't be for half a dozen years before you actually know whether it satisfies. There's a lot of simultaneous conditions batteries have to satisfy. The good news about this one is it's also not flammable at all.
Tell that to Boeing. Okay, one final question right over here.
So one of the interesting challenges with renewables like solar or wind is intermittency, including predictable intermittency like the sun rises and sets, as well as unpredictable like a cloud blocks the sun, on a 10-minute cycle or something. But there's also demand intermittency. And one of the interesting things about going to a smart grid is that it's easy to envision technology that ultimately makes it possible for you to start charging your electric car when the price of electricity drops below a certain threshold, for example. I'm wondering, what do you think needs to happen technologically and in terms of policy to make the grid more intermittent friendly in the end?
Well, for the first 10 years, I don't think the car manufacturers will really want you to be cycling your battery to do that energy arbitrage, right? Buy low at nighttime and sell back at, because of warranty. But in that same time frame, 5 to 10 years, the same technology can be installed in your home. It's a cheaper technology because it doesn't have to be quite as bulletproof, collision-proof, if you will. And that cyclability and everything is happening simultaneously. That is what's the utility companies are salivating over the time when they can buy a couple hundred kilowatts and put them in those little green boxes around the, in the distribution network, especially at the ends of the distribution network, because it would make the system much more robust to the things you were talking about. It would make it more immune to actually blackouts. It could make it more immune to everybody comes up at 5 o'clock and they want to charge their car, or at 7 o'clock, or if you're a physicist, 8 o'clock, and you want to charge your car, and physicists come together. So that's where I'm very, very keen on this, that the technologies in the next 5, 10 years are going in the right direction. The utility companies would love to have control over the charging. That's why it's so good for them to own the solar and the battery, because then they could figure it out and their system gets more robust. So, it's not, some people see it as a problem. I see it actually as a solution, that this is going to be a very good thing.
Thanks.
Thank you very, very much.